Okay, so this is problem number 8, page 687, exercise set 22C.2, Hayes and Harris, higher level mathematics. So we have a particle that's initially at the origin, it is not moving, and it accelerates according to this function right here. Okay, so let me get rid of my little marks there. Okay. The integral of acceleration gives me velocity. So I'm going to take the integral of negative, I'm going to move the negative out front, 1 over t plus 1 squared dt. Okay, so to integrate this, let's see, this would be equal to negative integral, what, t plus 1 to the negative 2, which is in the form of a plus bx to the n or whatever. So that's a simple integral to take. That would be equal to, coefficient of t is 1, so 1 over 1. And then we integrate as usual, add 1, and divide by the result. So let's see. So that would be 1 over t is 1, so that's my coefficient. T plus 1. Negative 2 plus 1 is negative 1 divided by negative 1, and negative divided by negative is a positive, so t plus 1 to the negative 1 plus c. But it is stationary, so I know that, oh, and this is v of t, right? So v of t. And I know that v of 0 is equal to 0 because we're told that it is stationary, it's not moving. So if I replace t with 0 here, then let's see what happens. So I get, I replace t with 0, so I would have 1, 0 is equal to 1 over 0 plus 1 plus c. So clearly c is going to be equal to negative 1, and so my velocity function is equal to t plus 1 to the negative 1 minus 1. Find the displacement for the particle. Okay, so this is going to be part B, and the integral of velocity is equal to displacement, or S I should say, sorry, that's our variable for displacement. So S of t is going to be equal to the integral of the velocity function. So the integral of t plus 1 to the negative 1 minus 1 dt. Okay? And that is equal to, I can separate these integrals. I guess I'll work it out. So this is equal to the integral of 1 over t plus 1 dt minus the integral of 1 dt. I really shouldn't even have to write the 1. Okay, this is a natural log function, 1 over ax plus b. So that is going to be equal to the natural log, absolute value t plus 1 minus t plus c. But we also know that s of 0 is equal to 0 since it's at the origin. So that means that 0 is equal to the natural log of the absolute value of 1, which is 1, minus 0 plus c. So that means c is equal to the negative, let's see, the natural log of 1 is 0, duh, so that implies that c equals 0. So that means my displacement function is equal to the natural log, absolute value t plus 1 minus t. Okay? So C, describe the motion of the particle at time t equals 2 seconds. So to describe it, I need to know its acceleration, its velocity. So I have velocity here, I have acceleration here, and I have displacement here. I will tell you that a of 2, using acceleration right here, is approximately equal to negative 0.901 meters per second squared. that v of 2 is approximately equal to, actually not approximately, it's exactly equal to negative 2/3 meters per second. Okay, and then let's see, S of 2 is equal to the natural log of 3 minus 2, which is approximately equal to negative 0.901 meters. So this was wrong. I copied the wrong answer. Acceleration is exactly equal to negative 1/9 meter per second squared. So to describe it, I'm not going to write all this out, but this is what you could say. The object, you start with the position, is approximately 0.901 meters to the left of the origin because this is negative. It is traveling to the left because the velocity is negative at a rate of 2/3 meter per second squared, and it's accelerating at a rate of negative 1/9 meters per second, which means it's slowing down. Okay, so that is it.